Okay, let's talk about how we would graph a rational function such as this one that we were using in the previous video. Y equals h of x is x divided by the product x plus 3 times x minus 2. You can see the degree of the numerator is strictly less than the degree of the denominator, okay? And it's all been reduced and everything. All the numerator and denominator are linear factors or products of linear factors. So this satisfies everything I want from the previous video. Okay, now let's go ahead and talk about some things here. First of all, I'm going to go HA, that's the horizontal asymptote. This will have a horizontal asymptote, which is y equals 0. Okay, what I want you to imagine, in general, this is going to be y equals q of x, whatever this quotient would be. Since the degree of the numerator is strictly less than the degree of the denominator, when I take the quotient, I get 0 with the remainder x there, which is being divided by that denominator or divisor, x plus 3 times x minus 2. Okay, so we already have this. What does that imply? That as x approaches plus or minus infinity, the graph of this thing is approaching the x-axis. Okay, now let's talk about vertical asymptotes. Okay, this can be plural here, right? Right, this has got to be unique, but these can be plural here. Okay, and you remember how to do that? I said if you've got it in reduced form here, what we can do is just take the denominator, set it to 0 and solve. That's going to be easy if I have it factored in linear factors. Okay, now we're only interested in real solutions. So if there is an irreducible quadratic in there and you got complex answers, those would be of no use for us when we're talking about a real graph. But at this point, I promise not to use any irreducible quadratic factors anyway. Anyway, so here we go. All right, I got x equals negative 3 and x equals 2. Now I want you to understand here that these are lines. I'm going to emphasize this. These are vertical lines. I really mean here the set of all points x, y such that, let's write it this one time, the set of all points x, y such that x equals negative 3. Okay, and the same thing over here, the set of all points x, y such that x equals 2. Okay, notice the domain is what? All real numbers except these two, right? Negative 3 and 2 here. Okay, now let's go ahead and do this. Let's go ahead and take r of x, the numerator. Remember I was calling out r of x. Find the zeros of r of x, if there are any. So that's the numerator. Okay, it's really remainder. What is r of x here? R of x is this guy up there, so that's x equals 0. So, oh, well, there's not really much to do, is there? It solves itself, x equals 0. So you see 0, comma 0. If I let x equal 0, y is going to be 0, right? So this is 0. The zeros of this here are at 0. And it would actually, what? This point 0, comma 0 would be on the graph of y equals h of x. I want to know the multiplicity here. What's the multiplicity? Okay? Well, you can see this is a simple 0. Multiplicity equals 1 also. All right? X equals 0 just one time. If that was x squared, that would have what? Multiplicity 2. If it was x cubed equals 0, that would have multiplicity 3. What is multiplicity with an odd multiplicity? What is that? It means it's going to cross, right? Okay. In this case, it's going to cross the x-axis, right? Okay. Because y equals 0, multiply on both sides by this, it's where r of x equals 0. Okay? Alrighty, find the zeros of this. Now, let me start drawing here. I don't know if you can see this very well, but I copied this out from Desmos, just printed it. Doesn't have to look perfect or anything, but I've got this written out. Okay, I'm going to put in the vertical asymptotes before I do anything else, some stuff I know so far. Okay, negative 3 and what? X equals 2. Just make those dashed lines, and I'll label them. I make them dashed lines because they're really not even part of the graph, right? They're important lines associated with the graph, but they're actually not the graph itself. And y equals 0, that's the horizontal asymptote. Okay, so I'm going to put that down there. We just have to remember that y equals 0, that's the horizontal asymptote for this thing. Okay, and we have another point, right? When x is 0, y is equal to 0. Now, do you remember what I was saying here? I was saying evaluate the actual function h of x at points between the vertical asymptotes and make sure that you're sampling at points which are different from the actual zeros of r of x. For example, when I talk about a sample point between -3 and 2, I'm not going to take 0. I already know what the function is. It's 0. Okay? It's actually 0. Okay? So let's do that. What would be a good point over here that might be an easy calculation over on this side? Okay? And when I say between these, I should say also, that means you're going to have to go between minus infinity and the first one that lies on the left, and positive infinity and the first one that lies on the right. That might not have been clear on my last video, but I sort of rushed through that thing. Anyway, how about at -4? That doesn't like it's too bad. So what I'm going to do is come over here and evaluate h at -4. Okay? So if we can do that. Here, let's write h of x again. That's x over okay. Now what would that be at -4? Okay, that would be -4 over -4 plus 3, -4 minus 2. That'd be -4, -1, -6. Okay. So that would be what? -2/3 actually, wouldn't it? Okay. So I don't know how this good this is going to look, but let's say that's that point right there. Okay. Now, how about, it doesn't matter where we do it right here. Let's take some point between -3 and 2. Let's take it 1. What would h of 1 be? That'd be 1 over 1 plus 3, 1 minus 2. That looks like -1/4, -1/4. So this would be what? Something like that. Okay? Could actually label these, I guess, if you want. -4 comma -2/3. This would be what? 1 comma -1/4. And then how about out here? Okay, we need one out here. How about at 3? What's h of 3? Okay, that would be 3 over 3 plus 3, 3 minus 2. Okay, that's really 1, so we've actually got 3/6 or a half. So we've got, this is actually 3 comma 1/2. Okay. All right, now I'm going to use a pencil here when I sketch this in here. Okay. Now let's talk about what this graph must look like. Now remember, these are vertical asymptotes, and what? The x-axis is a horizontal asymptote. So as x approaches infinity, minus infinity, it's got to be approaching that axis, and it's got to be doing that then. Okay? How come it isn't coming up like that? Okay, if it was coming up like that, then what? The function would have to be 0 somewhere in there. Okay. Oh, I forgot to mention this. I don't know. I wrote it down. Rational functions are continuous and smooth between vertical asymptotes. Okay. So you've actually got continuity here. It's got to go through that point. It's got to be asymptotic to these two. You know, maybe it looks like something like that. But if it did that, you know, it would have to cross somewhere, right? But it only crosses the x-axis, where this is 0, only where the r of x is equal to 0, and I already know where that occurs right there. Okay? Okay? Now, in between here, is it going like this? You know, these are vertical asymptotes. Is it going like this or something? Is it going like this? No, it's got to be a function, right? It's got to pass the vertical line test. You can't be doing this. Why? Why can't it be doing this? Well, do you remember that the multiplicity of the 0 at 1 was what? 1. That means it crosses there. So it's got a cross right here. I'll put a cross right there. Okay? So it's got to be doing this. It comes through this point. Okay. How about this guy? Can this guy be down here somewhere? No, it's got to go through this point. Okay? It couldn't be doing this. I mean, some graphs do this, but if you did that, you'd find there's what? You'd find there's an x-intercept there, but there isn't. The only x-intercept where y is 0 is it right there. It's got to be doing this. Okay, so that's a rough sketch of what this thing must look like. I hope you can see it here. Maybe I can move this down a little. Okay. All right, graph this on Desmos and see if I'm not right. I haven't yet, but I hope I'm right. All right, let's try another one here in a minute. Okay, let's do a second example here real quickly. It's a little more complicated than the first one, but let's go ahead and do it here. You'll notice here in this particular rational function, my k of x actually has what? Degree 4 in the numerator, degree 5 in the denominator. It's been reduced, and these are all linear factors. So this is the type of situation I've been looking at so far. Because the degree of the numerator is strictly less than that of the denominator, we know that a horizontal asymptote for this is y equals 0, the x-axis in other words. To find the vertical asymptotes, what do? You take the denominator, set it to 0 and solve. Okay, you can see the solutions would be what? Negative 3 and 4 here, so these vertical lines will be vertical asymptotes. Okay, we need to next find the zeros of the numerator, which I've been calling r of x, thinking of it as a remainder upon the division of two polynomials. So I take r of x there, 10 times x plus 3, x squared, x minus 2, set it to 0, right? And what am I going to do? I find negative 3, 0, and 2 as zeros with multiplicities 1, 2, and 1 respectively. Because the multiplicity here is odd, it crosses the horizontal asymptote, the x-axis, okay, at negative 3. Because the multiplicity is even here at 0, it's going to do what? The graph is going to bounce at the x-axis, and here where the multiplicity is 1 at x equals 2, it's going to cross, isn't it? Okay, so let's go ahead. Let's try to get a rough graph of the situation here. Let's put in the vertical asymptotes first. So the vertical asymptotes we said were x equals negative 2. So let's draw that in there as a dashed line and label it. And then we had x equals 4. So let's do that. Dashed line. Okay, since it's not actually part of the graph here. And then I'll actually label the x-axis, which we know is supposed to be a horizontal asymptote here. Now the next thing I'm going to do is go ahead and put down the zeros here. Okay, let's see, we had a 0 at negative 3, we had a 0 at 0, and we had a 0 at 2. Okay, and by the way, we have what here? I'll maybe put this in here, a little cross here, a little cross here. I'll leave that nice and round because I know that's actually going to bounce right there. It'll bounce off. Okay, let's consider what's going to happen now. I said what? Take, here's the best way to put it. Take a value of x in each of the subintervals of the real number line that's been broken up by the vertical asymptotes here. So I'll take a value of x out here somewhere. I'm not going to take it at any of the zeros of r of x though. Okay, so let's imagine what I did here was actually evaluate this at negative 5. H of x is negative 5 is negative 1.6. So we have something like this, negative 1.6 here. Okay. Negative 5 comma negative 1.6. Okay. And then in between here, see, I'm already cheating here. Took my points already at 3. I got so I just picked these arbitrarily, but I got 4.32. Okay. It's maybe a little under what it should be, but there it is. 4.3, 4.3. Okay? And now here at 6, I get 6.33. So this is going up there even further. Okay? Let's say this is 6, comma 6.3. Alrighty? Alrighty. So this is the idea for a graph here. Now, remember that these are vertical asymptotes here. So what's going to happen is the following. It's going to have to be asymptotic to this. Could it be doing this? I mean, it's got to go through this point here, and it's got to go through this point here. It crosses right here. Do you see what's going to happen? This thing actually does this. Now, it's going to have to come back towards the x-axis. If I keep going out here, remember it's asymptotic to the x-axis here. But what? It explodes, it skyrockets as I get close to -2. It's got to be doing that, right? Okay, to go through these points and cross there and have these as asymptotes here. How about this here? Well, it's supposed to cross here, bounce right there, and go through this point, right? Could it be doing this? No, it'd have to cross back through again, wouldn't it? It's got to be doing this then. Boing. And it's going to cross through here. And then it's going to be asymptotic. Right? There's a vertical asymptote. So these are going to get closer and closer together. How about this guy up here? Well, this is kind of exaggerated here. But this is actually pretty simple here. There's no zeros for the numerator or anything here. So what this does, it kind of slowly becomes asymptotic to the vertical axis here and the horizontal axis there. So this is kind of what it's doing here. Okay, I would urge you to go ahead and graph this on Desmos and make a quick comparison. It's a better picture here. Okay? Okay, I went ahead and graphed that last example on Desmos to compare it to what I got. And here was my drawing. Okay, the one we just got here. And here's Desmos. Okay, give you a better idea when you do it on Desmos here. Okay, qualitatively, I'm quite correct here, though. Okay, actually put those points in. Okay, alrighty, so it looks like we did pretty well. All right, let's look at some other type of problems here in another video.